10j. W equals negative 12I plus 4j. I want you to tell me what 2w is, what w minus v is, what 2v plus w is, and what 6v minus 4w is. Number 2, unit vectors in the same direction. Remember unit vector, magnitude of 1. Same direction, v equals negative 9, comma 6. Check your answers, please. Should have multiplied w by 2, would have gotten you negative 24 and 8. Should have subtracted the horizontal components and then the vertical components. W minus v, pay attention to the order. Order matters. So negative 12 minus 6 is negative 18. 4 minus negative 10 is positive 14. Remember, figure out what 2v is and add it to w. 2v multiplied by 2. 12i, negative 20j. And w, negative 12i, 4j. Well, notice that the i's cancel. Don't even need to write it. It's useless to write 0i. It means there's nothing there. Negative 20j, positive 4j means negative 16j. Now, if you think about this, I want to talk about how you could graph this. Negative 16j without any i's, well, that just means you're going negative 16 in the vertical component. So, like, if we ever see this, the way we graph it is you go vertically negative 16. So, go down 16. That's where it is. So, pretend that's negative 16, please. And that would be that vector right there. Now, for 6v minus 4w, make sure you multiply v by 6. And I did. Multiply 4 by w, or w by 4, I apologize. And I did. And subtracted. 36 minus negative 48, positive 84. Negative 60 minus 16, negative 76. For number 2, make sure you found the magnitude. That was the first thing. Magnitude ended up being 3 root 13. And then remember, divide both components by the magnitude. That's how we get it down to where the magnitude equals 1. Rationalize your answers from there. You should get this. So today we're going to be looking at a couple different ways to go backwards from what we've done before. First thing is going to be finding a direction angle. Well, the first thing is that a direction angle must be between 0 and 360. So it can't be negative, can't be bigger than 360. We're going to have a second bullet point in a second, once I get into the lesson. But for the third kind of part is it, well, to look at the direction angle. Well, for us, let's say it's in here. Then the direction angle is the way around this way. Alpha would be the direction angle. Or, if it's down here, the vector, when I said down there, I'm talking about the vector. If the vector is down here, then the direction angle is the whole way around. It's not this reference angle game that we've been playing with most of the tree. Go the whole way around. So copy down example 1. What is the direction angle of the vector that has negative 8, comma 8? Alright, let's graph it. Negative 8, comma 8. 1, 2, 3, 4, 5, 6, 7, 8. Comma 1, 2, 3, 4, 5, 6, 7, 8. There's this thing right there. There's our vector. And here's what I'm thinking. Based off what we've done before, I can make this into a triangle. I can figure out what that angle theta is going to be. Now, let's think about this. This is negative 8. That was positive 8. So I'm thinking, what trig function do I want to use to help me figure out theta? Well, they gave me the opposite, and they gave me the adjacent. So I'm going to want to use the tangent. Because think about it. If you wanted to use sine, well, then the hypotenuse. You want to use cosine. Same thing. Got to know the hypotenuse. And then if we think about it, we're going to want to solve for theta. So it's going to involve inverse trig functions. I'll explain why tangent is the smart decision in a second. So let's set it up. Tangent of theta equals opposite over adjacent, 8 over negative 8. So tangent of theta equals negative 1. I'm thinking to myself, which reference angle has a tangent that could be negative 1? We'll take the inverse tangent real quick. And if we think about it, then, well, that theta would be, well, negative pi over 4 technically. But think about it for a second. We're in the second quadrant. So if you think about it, the reference angle that has a tangent of negative 1 is going to be pi over 4 in there. And then do what we did before. If the reference angle is pi over 4, that's the direction angle. The direction angle, remember, is the whole way around. Well, if this reference angle is pi over 4, then, well, theta equals, not theta, I one thing. I want degrees. Well, through pi over 4, you guys know it's 135 degrees. So I know there are probably some questions about the negative pi over 4. Let's talk about that. Well, if you think about it, when you take the inverse tangent, technically it'd be in the 4th quadrant with a negative pi over 4 there. And remember, going around here, that is negative. So the reference angle is pi over 4. But remember, it's in this quadrant. So move it to pi over 4. Now, for the second bullet point, I want you to put in, always, use inverse tangents. And we described the first reason why. Because look at the parts they gave you. They gave you the opposite, they gave you the adjacent. So you want to use tangent. When I finish example 2, I'll explain the second reason why you want to use tangent. So let's look at example 2 now. What is the direction angle of a vector that has negative 2, negative 12? Let's graph it. Negative 2, negative 12, negative 1, 2, negative 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, negative 12. There, down there. Let's make our triangle again. Across there, down here. Triangle. And that's going to be the negative 12. It's going to be the negative 2. And let's make that theta. So if we think about it, tangent of theta has to be, well, what is it? It's opposite over adjacent. So negative 12 over, so that's the opposite. Adjacent's negative 2. So you got tangent of theta equals positive 6. Take the inverse tangent of both sides. Make sure your calculator's in degrees, okay? So let's look. Inverse tangent of 6. 6 inverse tangent. Now I'm getting 80.54 degrees in theta. So theta equals 80.54 degrees. Let's put those in there. 80.54 degrees. But remember, the direction angle goes all the way around. So if we think about it, you did that to figure out the reference angle. So it's really 180 plus 80.54. 260.54 degrees. Now, for my second reason why using tangent is by far the best idea. Every time you take the inverse tangent, think about it. Inverse tangent is only defined in the 4th quadrant and the 1st quadrant. So no matter what, it's going to give you a positive or a negative version of the reference angle. Look, that's what happened there. It was negative pi over 4, which pi over 4 was the reference angle. You look here, it came out 80.54, which was the reference angle. Well, then add it or subtract it from 180 or 360, depending on what you're doing. That's why using tangent is such a smart idea. All right, first you try today. What's the direction angle of 10, negative 4? What is the direction angle of 10, negative 4? You should have graphed it. Get your triangle. Well, you get that part's 10, that part's negative 4. Then use the inverse tangent. So tangent, negative 4 over 10. That's the opposite, that's the adjacent. And you get the theta equals negative 21 over 8. Well, here's the catch. We know that around that way is why it was negative, because we know it was in the 4th quadrant. Well, that part has to be 21.8 degrees. Now remember, your direction angle has to be between 0 and 360. And it has to go the whole way around. So if you think about it, if that part's 360, that part's 21.8, subtract it. You get 338.2 degrees. Alright, so you should have a worksheet in front of you that's titled Writing a Vector from its Magnitude and Direction. But before we get there, I want to take a couple notes. Remember from yesterday, the unit vector is given by the original vector v divided by its magnitude. Now if you think about it, we're going to be writing a vector, v, from its magnitude and direction. Well, based off of a lot of things, we can figure out a unit vector pretty simply. The catch is figuring out that vector. Well, I want to solve for v. So I'm thinking, what if I multiply by its magnitude? Those cancel. And I got v equals u. Actually, no, let's flip it the other way around. The magnitude of v times u. Now let's talk about that u really quick. That u, well remember, that's a unit vector. Remember what a unit vector required? It required its magnitude to be 1. So think about the unit circle. That's where these come from, honestly. So that's a 1, that's a 1. Remember, the unit circle is going to go around this way. Now, if you have a unit vector on the unit circle, ladies and gentlemen. On the unit circle. So think about it. The x-coordinate. X-coordinate can be cosine or sine. You're on the unit circle. It can be cosine. And the y-coordinate, if you think about it, is going to be the sine. Where in the world am I going with this, you ask? Well, if you think about it then, your horizontal component and your vertical component of the u vector, I want to look at that now, the u vector. Think about it. Remember, this way out there is the I direction. This way up here is the j direction. So if you think about it, we can replace u with, well, if we had to write a vector to describe this, the cosine of alpha would give us the x direction, because that's the x-coordinate if you think about it. We draw a triangle. This would be the x-coordinate, the cosine of alpha. So that would give us cosine alpha I, because that's the horizontal component, plus, well, we need the vertical component next. Well, that would be the sine of alpha. Sine of alpha, j. So the next thing I want in your notes is that the big vector v is equal to its magnitude times, and this is going to be our new interpretation of the unit vector, cosine alpha I plus sine alpha j. And this part should make sense, because think about it. Your horizontal component has to be the cosine if you're inside of a unit vector, because the unit vector is inside the unit circle, guys. And then your vertical component has to be the sine, because you're inside the unit circle, and the vertical component will be given to you by your y-coordinate, which is the sine. Now let's look at example 1. You already got that on your paper. My sister felt like filling you in. Gonna have some more problems. So, go ahead and read the problem. A ball is thrown with an initial speed of 25 miles per hour in a direction that makes a 60-degree angle with the positive x-axis. What is the initial speed in the horizontal direction? And what is the initial speed in the vertical direction? First thing, a ball is thrown with an initial speed of 25 miles per hour. Initial speed, 25 miles per hour. Look back at your notes from day 1, from Monday. Magnitude, I said it's length or speed in applications. Application is speed. So this tells you your magnitude. Now, the next question is, well, let's draw it real quick. Let's see, because this next part is going to be best by drawing. Well, let's see, it's thrown with an initial speed of 25 miles per hour in a direction that makes a 60-degree angle with the positive x-axis. 60-degree angle with the positive x-axis. So we know it needs to go out that way with a 60-degree angle. That's how you draw a 60-degree angle with the positive x-axis. And we know its magnitude has to be 25. Well, looks like we got ourselves this situation right here. We can plug it into the formula. So, the vector equals, well, the magnitude of v, we know that was 25. 25 times cosine of alpha I. So cosine alpha 60. 60 degrees I plus sine of 60. Well, from here, you gotta simplify it. Equals 25 times the cosine of 60 degrees. 1/2. 1/2 I plus the sine of 60 degrees. That's root 3 over 2. J. And now distribute the 25. Equals 25 over 2I plus root 3. 25 root 3, I apologize. I need to distribute the both sides, not just one. 25 root 3 over 2 j. And that's going to be the vector we need to answer these questions. So we know that the big vector was 25 over 2I plus 25 root 3 over 2j. Now to actually answer the questions they gave us. What is this initial speed, the initial speed in the horizontal direction? Now think about this for a second. The horizontal direction, that would be I. So it's asking, what's the initial speed in the I direction? Right there. The initial speed in the horizontal direction is 25 over 2. Now you know that's 12.5. I would prefer decimals on these over fractions. So it is And then if it says, what's the initial speed in the vertical direction? Well, the vertical direction, that's the J component. So figure out what that guy is as a decimal. So do 25 times 3 square root. I got 43.3 divided by 2. And that told me 21.65. So 21.65 miles per hour in the vertical direction. And just really quickly, I double checked that these answers make sense. We know that both of them have to be less than 25 miles per hour because, well, if you think about that triangle, the 25 miles per hour would be the hypotenuse. So its diagonal speed has to be the greatest. Now, then I analyze these real quick. Should the vertical direction be bigger than the horizontal direction? Well, yeah, because 60 degrees, if you think about this right triangle, if this is 60, then that's 30. Well, 60 degrees opposite has to be bigger. That was the 21.65 in the vertical direction. So yeah, the vertical direction has to be greater than the horizontal direction. So I know my answers are correct. Alright, Crazy Dave Ziplines has set up a zip line that makes a 10-degree angle with a positive x-axis. It has zipliners going 272 feet per second initially. Express the velocity vector v in terms of I and j. At what speed are the zipliners approaching their destination initially? That is horizontally. At what speed are the zipliners approaching the ground initially? Well, first thing, when I read the problem, I notice 272 feet per second has to be our magnitude. Just remember, look back in your notes. That's what magnitude was. Second thing, 10-degree angle with a positive x-axis. So I'm thinking I can draw a picture that can show this part right here. So let's do that. A 10-degree angle with a positive x-axis. Now here's the catch. Zipline. Ziplines go up or ziplines go down? Ziplines go down. You need gravity to help you out. If you're going to have a zipline going up, you're not going to go that far. So, zipline goes down. Now it makes a 10-degree angle with a positive x-axis. And we know the magnitude is 272. We're almost good to go just to plug it into the formula. One other catch. Remember, you've got to plug in the direction angle. Now, the direction angle is not 10. Because remember back to example 1 all the way at the beginning of today. Direction angle is the whole way around. So if that's 10, and this guy's 360, then your direction angle alpha is equal to 350 degrees. And that's what you're plugging in there, not the 10 degrees, 350. Think about it. You know this has to be negative. You plug in 10, it's not going to come out negative. Plug in 350, that part's going to come out negative. Let's start plugging it in. V equals, remember the formula. Its magnitude times our new definition of the unit vector. Remember the unit vector was cosine alpha I plus sine alpha j. Which would make sense because you're in a unit vector. There's a radius of 1. So the cosine is the x-coordinate and the sine is the y-coordinate because you have that radius of 1. Now, let's see. V equals, the magnitude was 272 times the cosine of 350 degrees I plus the sine of 350 degrees j. Well, the way I want you guys to do this is do it in one fell swoop. So get your calculator out. Make sure it's in degrees. Do 350 cosine times 272. And that comes out 276.87. So this equals 280s. Or sorry, that was 267. 267.87 I plus, and then do 350 degrees, 350 sine times 272. And that comes out negative 47.23. So no more plus, because that came out a minus. Minus 47.23 j. There's your velocity vector in terms of I and j. So I want you to start doing this in one fell swoop. 350 cosine, get an answer, times 272, right there. 350 sine, get an answer, times 272. And it should come out negative. Now, let's answer the rest of it. It said, at what speed are the zipliners approaching their destination horizontally? Well, if we think about it, their destination ask questions like that, you don't even get to see the word horizontal. Because that's what they're implying by at what speed are they approaching their destination? Well, they're talking about the horizontal distance. If they want to talk about this, they would talk about the speed on the zip line, which is what we started with. Well, we need to look at the horizontal speed. Well, the horizontal speed is right there. So we know that it's 267.87 units, feet per second. Feet per second? Horizontal. Just tell me that. And then for the vertical distance, or the vertical speed, well, the negative is just telling us what direction it goes. The speed is really 47.32. I can't say anything right. 47.23 feet per second. Vertical. If you think about it, that's definitely going to tell us at what speed the zipline is approaching the ground. Because well, the ground is going to be the vertical height. Alright, so go ahead and check your view tries, please. For number one, well, you know that it said a plane had descended on the runway with an angle of depression of 50 degrees. That's what an angle of depression is, or an angle of descent. Same idea. And then its speed was 900 miles per hour. So we know magnitude 900. But you couldn't use the 50, you had to use 310. Because 310 is the direction angle. Remember the way we got that? 360 minus 50 gave us 310. So now plug it in. Cosine of 310, I, plus sine of 310, J. You distribute the 900. And you get 578.5I minus 689.43J. Now answer the second question. The second question asked, at what speed is the plane approaching the ground initially? Well, if it's approaching the ground, that's the y component. The vertical component. Well, you can't go negative speed, so it'll be 689.43 miles per hour towards the ground. And then, well, at what speed is it approaching the tip of the runway? Well, that's the horizontal speed. And that has to be 578.5 miles per hour. On number two, make sure you notice that it said that John throws a rock with an initial speed of 10 feet per second in a direction that makes a 30-degree angle with the x-axis. 30-degree angle with the x-axis, that has to be 10 because that was the initial speed. Plug it into the formula. Cosine of 30, sine of 30, cosine of 30 is 3 over 2, sine of 30 is 1/2, distribute, and you get 5 over 3i plus 5j. Now to answer the last two questions. What is the initial speed in the horizontal direction? Remember, I don't want a root, I want a decimal. It'll come out 8.66. And then what's the speed in the vertical direction?